In this video, we're going to talk about what we do in the case of a mixed strategy game. So if you remember in class, we talked about a few dominant strategy games. So if there's a dominant strategy, that means that there's one choice that's going to be right for you, no matter what the other person does. But in a mixed strategy game, like we have here in the Battle of the Sexes, there's two Nash equilibria. And which is right for each of the player totally depends on what the other player is going to do. So they're kind of stuck here in this battle of wits between each other. So what do we do with this? Is this just going to be a guess between the two parties? Do they just have to fly blind in this scenario? Well, there's a few different strategies that we can use here to make a probabilistic guess. There's never going to be a certain strategy here. But there are some good ways that we can make this more likely to play out in our favor. So the way that we're going to think about this is if I'm the husband and I'm trying to think about my decision of going to the fight versus going to the ballet, I know that there's some probability that my wife is going to pick fight. So we're going to call that probability sigma. That's the Greek letter we're going to use here. So there's some probability that she's going to pick fight. And then it's necessary, if that's sigma, then the probability that she chooses the ballet is 1 minus sigma. So remember that probabilities always add up to 100 or to 1, right? And so the probability that if the probability that she chooses the fight is sigma, then the probability that she chooses ballet is 1 minus sigma. So it could be a 50-50, it could be a 60-40, 70-30. This distinction is important because what it allows me to do then is to say, okay, if I'm going to choose fight as the husband, well, I can take these probabilities that the wife will choose fight or ballet to find the expected utility of me choosing fight. By expected utility, what I mean by that is essentially the average. So let's say we played this game 100 times over, and every time I, as the husband, picked fight. Well, if I know what the probability of my wife choosing fight or ballet is, then I could calculate on average, if I pick fight every time, on average, what's going to be my utility. And then I could do the same thing for ballet. I could say, okay, if I picked ballet every single time we played this game 100 times, what would be my average utility? Well, if my average utility for fight was higher than my average utility for ballet, then rationally I should choose fight because on average I'm going to get a higher payout if I'm always choosing fight. So let me walk you through now how we do this mathematically, okay? So the expected utility, we'll start with expected utility of fight. So it's going to be equal to the probability that the wife chooses fight, so sigma, right? That's the probability the wife chooses fight, times the utility, the payout, if the wife chooses fight. So if I'm the husband and I'm choosing fight, and then the wife also chooses fight, then I get a payout of 2. So it's the probability that the wife chooses fight times the payout if the wife chooses fight, plus the probability that the wife chooses ballet, which is 1 minus sigma, times the payout if the wife chooses ballet, which in this case would be 0. Okay, so now we've got a little formula here that shows us what the expected utility, again, that's like the average utility if we were to play this 100 times, would be if I, as the husband, always chose fight. So let's give an example to show how this works. So let's say that the wife is 50-50. So 50% of the time she'll go fight, 50% of the time she goes ballet. Well, we can plug those values in here. So 50% times 2 plus 1 minus 0.5, so that's also 0.5 times 0. Well, this is going to cancel out, and then we have 0.5 times 2, so this equals 1. So what this is saying is if I, as the husband, picked fight every single time, and if we played this game 100 times, well, 150 times out of 100, she's going to pick fight, and I'm going to get a value of 2. And 50 times out of 100, she's going to choose ballet, and I'm going to get 0. So on average, I'm going to get 1. That's the idea behind this expected utility. Okay, we can do the same for ballet. So expected utility of ballet is equal to the probability that the wife chooses fight, which is sigma, times So again, now I'm looking up here at ballet. And if I choose ballet and the wife chooses fight, then I get 0. Plus the probability that the wife chooses ballet times the payout that I would get if I choose ballet and the wife chooses ballet. And that would be 1 in this case. So let's use our 50-50 example again. So if it's a 50-50 example, so we'd have 0.5 times 0 plus 0.5 times 1. This would cancel out. 0.5 times 1 is equal to 0.5. Okay, great. So in this case, if we played this game 100 times and I chose ballet every single time, well, 50 times out of 100, she's going to choose fight, and I'm going to get nothing. And 50 times out of 100, she's going to choose ballet, and I'm going to get 1. And so on average, I would get 0.5. Now, you'll notice that if we compare these two here, on average, it pays out for me to choose fight. So if I know that my wife is a 50-50 toss-up, then it's rational for me to decide to pick fight each time. Because on average, maybe in one game I'll lose and I'll get 0. But on average, that decision is going to pay out for me more if I know that my wife is 50-50 on the decision between fight and ballet. Now, if this is true, then it also implies that there is some cutoff point where the expected value of choosing fight is equal to the expected value of choosing ballet, where these two numbers are equal. And in that case, I would be indifferent. If both decisions pay out the same on average over time, then I have no incentive to choose one versus the other. This is a helpful point for us to distinguish because that's the cutoff point where we say, though, if the wife's probability of choosing fight versus ballet is at this probability, then I know that I'm indifferent. So if it's higher or lower than that, then I can make my strategy. So here's how we find this cutoff point. So what we want to find is the point where expected utility of fight, of me choosing fight, is equal to the expected utility of ballet. I want to find the probabilities for the wife choosing fight versus ballet that make my expected utility as a husband equal, regardless of what I choose. So what we're going to do is we're going to just plug in these equations up here and set them equal to each other. So the expected value of fight here, so we have sigma times 2 plus 1 minus sigma times 0. So that's the expected value of fight. That was up here, right? So we're plugging that in here, and then we set that equal to the expected value for ballet, which is right up here. So sigma times 0 plus 1 minus sigma times 1. Okay, so now what we're going to want to do is we're going to solve this entire equation for sigma. And that will tell us the sigma, or the probability of the wife choosing fight, that makes me as the husband indifferent. I don't have a strategy at this point. Okay, so let's start combining terms here. So we know that this is all going to cancel out because it's timed by 0. This is all going to cancel out because it's timed by 0. Okay, so we're left with 2 sigma is equal to, and then we can distribute this, 1 minus sigma. Okay, so we'll add sigma to this side and to this side. So we have 3 sigma equals 1, and then we'll divide both sides by 3, and so sigma equals 1/3. So this tells us that if the probability that the wife, again, sigma is the probability that the wife chooses fight. So if the probability that the wife chooses fight is 1/3, which means that the probability that she chooses ballet would be 2/3, right? 1 minus sigma. If those are her probabilities of her making those decisions, then I, as the husband, don't have a strategy, because either way that I choose, whether I choose fight or ballet, it will pay out the same on average over time. So now what I can do though is I can say, so let's say that her probability is greater or less than 1/3. How do I let that inform my decision? Well, what we can also do is we can just change equals up here. If we just change that to greater than, then what this tells me is I want to know the point at which the expected value of fight is greater than the expected value of ballet. And if I change the equal sign there, I can also change it here. So I also know that expected value of fight, of me choosing fight, is going to be greater than the expected value of choosing ballet if the probability that the wife chooses fight is greater than 1/3. So if I think that my wife is going to choose fight more than 1/3 of the time, then I should choose fight. If I think it's less than 1/3, then I should choose ballet. So now I have a criterion point, I have a cutoff point where I can decide between the two and say, well, do I think my wife is more or less likely than 1/3 of the time to choose fight? So that's how we approach a mixed strategy game, is we're going to try and calculate here the expected utility or the utility that we get on average from both of these decisions based on the probability of the other player making those decisions. And now we have a cutoff point. Feel free to practice this a few times to make sure that you can replicate these, and we'll answer any questions that you have in class.